Consider a particle of mass m on the axis of the ring and mass capital M of mass capital M and the radius r at the distance r from the center of the ring. This particle moving under the gravitational attraction of the ring reaches the center of the ring. The velocity of the particle at the center of the ring will be equal to. If I consider a ring over here, let us say its radius is equal to small r and a particle is situated at a point O, or let me call this as point A, and let the center of the ring be equal to O at a distance x from the center of the ring, at a distance of x from the center of the ring. So if I consider an elemental length dm, due to this there will be a small potential energy on this particle of mass m. There will be small potential energy on this particle small m. This small potential energy, let me write this as du, it will be equal to g small m dm divided by r square, where r is the divided by r. So this distance is equal to between point A and let us say this point as C. Okay, it will be equal to x square plus r square. So root of x square plus r square. So I can write this part as x square plus r square the whole raised to half. Now this is the potential energy due to the small elemental length. Okay, due to the elemental length. Okay, if I want to find out the entire potential energy, I have to integrate this part. Okay, now it is a scalar quantity, so it will be equal to g small m, instead of dm, when I integrate dm, it will be equal to capital M divided by x square plus r square. Okay, the whole raised to half. Okay, now in the first case, when the body was situated at point A, okay, when the body was situated at point A, its potential energy would be equal to, its potential energy will be equal to, its minus, okay, it's minus over here. So its potential energy over here will be equal to minus gmm. When it was situated at point A, the distance x over here is equal to r. The distance from the center is given as r. So basically it will be equal to r square plus r square raised to half. So basically it will be equal to 2r square raised to half, which will be equal to minus gmm divided by root 2r. Okay, let this be equation number 1. Okay, when it was at the center of the ring, the distance of x will be equal to 0. The x will be equal to 0. When x is equal to 0, u2 will be equal to minus gmm divided by r. Okay, when x is substituted as 0, it will be r square raised to half, which will be equal to r. So basically so I can say that as it reaches the center of the earth, center of this ring, it will have certain velocity. Let that velocity be equal to v. So I can say that the total energy at the position A will be equal to total energy at the position O. So total energy will be equal to the kinetic energy at the position A plus the potential energy at the position A will be equal to kinetic energy at the position B plus potential energy at the position B. So when the body was at the position A, it did not have any velocity, so the kinetic energy will be equal to 0. Minus the potential energy is given as minus g small m capital M divided by r into 1 by root 2. Okay, I am writing 1 by root 2 separately. Kinetic energy at the body B, at the position B, let it be equal to half mv square, minus the potential energy is equal to minus g m divided by r. Okay, so basically we have to find out the velocity. So the velocity over here will be equal to, first of all, m will get cancelled out everywhere. Okay, so it will be equal to half v square is equal to gm by r can be taken as common. Okay, it will be equal to 1 minus 1 by root 2. Okay, so basically over here, if I see the options, v will be equal to 2gm divided by r 1 minus 1 by root 2. Okay, this will be the total velocity, 2 gm divided by r 1 minus 1 by root 2. Okay, which is equal to over here option number D.